Hello everyone. I am Wada from Next Vision. Today I'll be talking about visual disability and the latest in assistive devices. I have a acquired low vision, vision loss, and I'm today totally blind. And today I would like to talk about what problems we people with visual disability have and how we try to use technology to solve the problems. So I have a acquired low visual loss. When I was in second year of junior high school, I was diagnosed with progressive retinal disease. From senior high school, I then entered a school for the blind, and at this time I had symptoms for visual field constriction and night blindness. But even then I had a 20/20 vision, but gradually my vision declined, and when I was 30 I could not read text, and when I was 35 I could not identify the colors of the traffic light. And when I was 55, I could not tell whether the light was on in my room. So it is not totally black, so I'm not quite sure when exactly I lost my vision. And as for some of the problems I have as a person with a visual disability, with respect to visual field constrictions, because my field of vision is small, I'm not very good at the ball games, and it is difficult for me to look for things when I drop something, and also when I go out into a crowded place, I bump into people, which makes mobility difficult. And I also have night blindness and photophobia, and I can see when there is where it is light, but when it is dark it is very difficult, and I cannot go out at night. But when it is too bright, I cannot keep my eyes open. And as for loss of vision, when we lose vision, we are not able to read text. For example, newspaper, books, or flyers we cannot read. And also information displays and bulletin boards we cannot read. We have difficulty filling out various agreements and contracts. And also various devices, and they have displays, but we cannot see the displays, and therefore we cannot operate those devices. So mainly people with this visual disability have problems with reading and mobility. For people with low vision, we can use some of the vision that is remaining, and there are various visual aids. For example, magnifying glasses and tinted glasses that helps to alleviate brightness. And in recent years we have smartphone app and also eyewear devices. And I would like to explain some of these devices. First, we have an app called a Brighter and Bigger, which is available in both the iOS and Android smartphones. You use a rear-facing camera, and you can enlarge, invert the colors, or improve the contrast so that we can better read the text. If you have a smartphone, you can use it as an electronic magnifying glass, and there is also a video magnifier. In addition to paper-based books, there are electronic books today that can be used by PC or smartphones, where you can enlarge the text. There are digital textbooks as well. And by using a UD browser, you can read digital textbooks on iPad. Professor Yasushi Nakano, who is a professor of economics at Keio University, have collaborated with textbook companies and teachers in schools for the blind to develop this UD browser. This also has a screen reader and dictionary search functions. It is available for PDF files as well as HTML files. Next is a night vision glasses, MW10 Hikari. So there, at the center of the glasses, there is a small camera mounted, and on the temples of the glasses, on both sides, there is a small projector. So this is a eye wearable device. It is good for people who have visual field constriction and night blindness. It provides expanded and brighter field of vision. It was developed by a company called Hoya. It uses low light intensity, high sensitivity camera and can be used in a darkness of 0.6 lux. It has a wide angle lens to provide an expanded field of vision for those people with visual field constriction. So I would now like to talk about the technological innovation that I experienced in terms of visual aids. In the 1980s, we were able to read and write on paper using a device called Opticon. This device converts text on paper into tactile information. It will require training to be able to use this device. I can read numbers and some text using the Opticon. There is also a Braille word processor that can print out text in Japanese characters. So even if you have visual disability, you can produce an output in text. And this device converts Japanese characters into Braille. It was difficult for me to learn the kanji characters and the corresponding Braille. But today we can use the hiragana and katakana text to convert into Braille, which has made things much easier. And in the 1990s, it became possible for us to read and write electronic text, which was quite revolutionary for people with visual disability. We can now use electronic books, internet and OCR to convert text on paper into electronic data and then produce output in speech or in Braille. And with this technology, we have a same accessibility to text as people without visual disability. Of course, there is a Japanese dictionary that is provided in the form of electronic book. In the 2000s, there has been a use of advanced IT networks, including social media, and information terminals have been miniaturized into a form of smartphones that can be carried in a pocket. And there is also the use of cloud that provides access to information anywhere at any time. In the 2010s, the artificial intelligence, the AI, was developed to provide a better visual aids. By using smart speaker, we can give out instructions in voice. There is also wearable devices, electronic payment systems, and the use of Internet of Things, IoT, to operate various household appliances. The electronic payment system allows us to make payments and to use trains even without buying tickets in particular. So that has reduced the burden on people with visual disability. In the 2020s, we now have virtual reality and visual enhancement features. And for work and various events, we can now perform remotely, which has helped people with visual disability who have problems in terms of mobility. There are now robots as well as 5G communication, high-speed communication, that provides remote mobility assistance. There are new technologies such as VR, AR, and MR that provides a new kind of environment. Next, I would like to explain some of the electronic devices to support reading and writing. As I mentioned earlier, this device is called the Opticon, which was first developed and sold during the 1970s for us to read text from paper. It has a CCD camera to capture the text, and this is converted into a 24x6 array of 144 pins that produces vibration, and the user would place the left hand to read the converted information. And it takes some time to be able to use this device. You need some training, but some people can even read Japanese dictionary by using the Opticon. This device continued to be sold until 1996. And after Opticon was developed, after 50 years after the Opticon was developed, we have a new device called the Oton glass. So this device is attached to the temple of your glasses. There is a small camera mounted and sends information to the internet cloud. And there the AI will recognize the image and read out the text in Japanese. And even if the text is in a foreign language, this device will translate the text into Japanese. So it solves the problems if people cannot read foreign language, and it also solves the problem of visually disabled people who cannot read. This kind of AI visual aid have been developed since several years ago. And here are the list of some of the visual aids devices that are sold in Japan. They include Oton glass, Ocam My Eye 2, Angel Eye Smart Reader, Envision glass, Dyna glass, Remote Assist, and night vision glasses MW10 Hikari. This is a Oton glass which was developed by Japanese venture business. It is connected to the internet. You turn the camera to the text and press a button to read a text. It's very easy to use. It uses the Google Cloud services, and it can use multiple languages. The price is 198,000 yen, which is about $1,800, and you can connect to the wireless. Opticon My 2 is the next one, which was developed by an Israeli company. You attach a camera, a small camera, on the temple of your glasses. This you do not have to connect to the internet. It reads text as well as recognize people and objects, banknotes, barcodes, and differences in colors. You use your fingers to provide instructions. The price is 498,000 yen, about $4,500. And if you were to use only the screen reader function, the price is half. Next is Angel Eye Smart Reader. Was developed by a company in China. Similar to Opticon My Eye, you attach a small camera on the temple of your glasses. This device does not have to be connected to the internet. This is specialized for reading text, and it will convert the text into speech. And when the text is within the scope of the camera, it will capture the image automatically. The price is 198,000 yen, or $1,800. Next is the Envision glasses that was developed in the Netherlands. You need to connect to the internet. As for the hardware, it uses the Google Glass Enterprise Edition 2. It reads text as well as explain the scenery around you. It can detect colors and lights, banknotes, objects and people. It can find certain objects and people, and it has a telephone function. So you can connect with the registered volunteer and ask him to look at the image captured by the camera. The price is 462,000 yen, or $4,200. Next is Dynaglass, which was developed by a Toshiba company, Toshiba. It is connected to a portable PC and worn around your neck. The AI would analyze the surrounding environment. It can read text, it can recognize traffic lights and people, and it can provide explanation about the surroundings. It provides information at few seconds interval to the user. And also the Cloud Core Engine has a machine learning feature to improve usability. The price is 249,800 yen, which is about $2,200. And in addition, you have a user fee of monthly $60. Next is Remote Assist, which combines wearable camera and Android transmitter. It is connected to the internet. Through matching, you can use the matching server to connect to a volunteer for support. The volunteers are from the Japan Remote Assistant Association. The price is 198,000 yen, or $1,800. If you are to use a SIM type, you have a communication fee of about $20. Next is night vision glasses MW10 Hikari. This is good for people who have a night blindness and visual field constriction. This device was developed by a company called Hoya, but in 2021, this business was transferred to another company called Vixion. The price is 434,500 yen, or around $4,000. This picture shows the latest model, the 2021 model. The design of the eyewear has been changed with the help of Mr. Oki Sato and Nendo. As a new feature, it has a remote chat. You can have a Wi-Fi connection to the internet and have a remote chat with a registered volunteer. You can have the volunteer look at the images captured by the camera and communicate by remote chat, and this will cost about 500 yen per month. There are also smartphone apps that provide various kinds of visual aid. One is Seeing AI, which was developed by Microsoft. It recognizes text. It can detect light and color, banknotes, people and objects, and surrounding scenery. So it provides many features. Be My Eyes is another smartphone app developed in Denmark. It is used globally. It can also be used in Japanese. And if you need, it also matches people who need support and volunteers who provide support. You can show the image to the volunteer and communicate by phone. And so if you are having problem reading, or for example looking for some articles, then you can connect to the volunteer. A similar mechanism is available in Envision glass. One is Envision Alley and Envision AI. This Envision AI has a feature where it can recognize handwriting. So this is Oka My Eye 2, and here there's a magnet attached, so you can attach the device to the temple of your glasses, and it also has a strap so you can put it on. Now I can read text. So the feature of this device is that you can use hand gestures to give instructions to the device. So let me show you. So here is a printed paper, and I point with my finger. And it is reading out the text. The recognition is not very good, but it is reading out the text. And to stop reading, you give a hand gesture to stop, and it will stop reading. And so the feature of this device is that you give instructions by hand gesture. And in addition, it can also recognize banknotes. So I have this banknote here. I will let the camera read it. And it will read out. the banknote. And this one is an Envision glass. I can recognize things that are in the surroundings. So it says explore. And this camera will recognize. It says suitcase, chair. So you would know what is in the surroundings. It says television. And here it can also recognize different colors. And the other feature of this device is that it has a telephone function. It says making call. And it says call volunteer. Now it is connecting. So I'm calling my son. So we are connected now. Can you hear me? So I have this ramen noodle, but I want to know what the brand is. Can you see? Is that angle correct, right? Like this? Oh, it says Natsukashi no udon. Now I would like to explain some of the electronic devices to support mobility. Here I am holding white cane in my right hand and a supersonic sensor in my left hand, and I'm skating on ice. So the black small device that I was holding in my left hand is called palm sonar. You hold it in your hand. It is a small supersonic sensor. It can recognize objects in front of you, and it will give a vibration if the object comes within the distance of 4 meters, and the speed of vibration comes faster when the object comes closer to you, so that you can tell the distance to the object. By using the white cane together with the sensor, we can move around safely. The price is 81,000 yen, which is about $1,730. However, this device is no longer manufactured. Next one is a smart cane. And this cane has a supersonic sensor. It can recognize objects within the distance of 2 meters. It will give you a vibration to let you know there's an object. It can recognize objects in front of you and above. You can simply turn on the switch to use this device. You can keep both of your hands free while walking. The next one is WeWalk Smart Cane. This device was developed by a totally blind engineer in Turkey. It also has a supersonic sensor, and it can tell obstacles at levels above your chest by giving out vibration. Through Bluetooth, it can be connected to the smartphone. It is rechargeable. The price is $499. Next one is Navi Lens, which is a smartphone app. In Spain, there is a colorful two-dimensional codes that are used in public spaces. If you capture this code from within 16-meter distance, information can be recognized. It can tell direction, distance, and angle, and it reacts very quickly, so it helps us in terms of obtaining information while we are moving about. This is available in Barcelona, in New York subways. And in Japan, there is a demonstration test have been performed in Kobe. So by using iPhone magnifier together with the voiceover function, it can convert images into speech. And if you use the iPhone 12 Pro, it has a LiDAR sensor which tells you the distance between you and another person. So this kind of new technology is helping to improve the quality of life for people with visual disability. It is almost revolutionary. So lastly, I would like to show you the use of Navi Lens, an iPhone human detection feature that has allowed me to skate on ice. On my right hand side is a white cane. On the left hand side is a supersonic palm Sonar. And on my chest there is two smartphones. And I'm skating. Navi Lens tag have been located on the four corners so that I would know where I am skating. So today, instead of my own eyes, I have used my smartphone cameras. On the lower hand side is iPhone 12 Pro Max, and on the top is the iPhone SE2 cameras, which recognizes the Navi Lens tags. So by using two smartphone devices, I can skate on ice. Changing what was impossible into something possible. This gives hope to many people. I look forward to your new ideas. Good luck.